Hello guys, welcome back to Math Zone African Motives. We are still on our mathematics N6, still working on our differential equations. In this case, we shall be focusing on the question paper which was written in August 2021. So this is August 2021 exam, where we are given on question number 4. All right, so this is the first part of our question. Calculate the particular solution. So we know that the particular solution is the one that we're going to use with the given situation that we have here. We are given a point 20 here. So this point represents the x value. So there they gave us what is corresponding to the x and y in this case, like it's a point, all right, x and y. So meaning to say we are given the value of x, which is 2 at a condition where y is equal to 0. We shall talk about that in the calculation of what? Of the particular solution. But we know that the first thing, we need what we call the general solution. All right, so this is it, guys. Let us not waste much time. That's 4.1. The derivative, that is dy dx, in this case, minus y over x, ln of x like this is equal to 1 over x at a point 20. All right, so this is taken at point what? At point 20. Okay, so what is it that we are supposed to do? We are supposed to have the format. This is a linear, which is we're talking about the first order linear, which is taken from this format that we are given here, that it must be of the form dy dx plus py is equal to q. Therefore, we shall simplify that or integrate that in this format. So this is the format that we shall have, and I shall talk about this. All right, so we have the format there. First, let us talk about this format. Are we having exactly the format that we are given? If we check here, this is exactly the format that we are given here. That is dy dx is supposed to be like this, dy dx plus py is equal to q, where p and q are functions of x. So if we check properly, here we have got functions of x. We're just going to have to write this in terms of functions of x. So this is going to be dy dx minus, we need to see properly p, the function of x. So we're going to add this, like we're going to write as a plus, then we're going to have a minus, so that we have this format plus p. We are supposed to properly see the p. All right, we are not supposed to see this as a minus. We are supposed to properly see the plus that we are given there on the formula again as it is. All right, this is the format that you're supposed to have. So this is the part that I want us to remove. So you're going to remove this part here, 1 over x ln x. All right, so this is the part that you're going to remove. So it will be minus 1 over x ln of x like this. So this is what we have, times this y like this, which is equal to 1 over x. All right. So once you have this format, once you can write in this format here, where we can properly see our p and our q. This is our p here, and this is our q on this part. Once we can see this, the format is stating that therefore this is going to give us, from that formula we are given that therefore all right, sorry for that. So therefore we shall have the integral given as, it was given as a y in this case. This is ye to the integral of p with respect to x, which is equal to the integral of q. Then we have got again e to the exponent of the integral of p with respect to x like this, dx. So what is this format? What does this format mean? That is the question. What does this format mean? It means that we are supposed to have the integral of p, which is called e to the exponent of this integral is called the integral factor. All right, this is referred to as the integral factor. I talked about this, but for the sake of revision, I'm just going to rewrite this also. So like I said, this is referred to as what? As the integral factor, like this. So we're going to have our integral factor, which is e to the exponent of p, this part of p. So this is our p. So it's p with respect to x like this. This is referred to as the integral factor. So meaning to say we are supposed to have e to the exponent of the integral of this. Take note, what we are supposed to have in this case, the integral of minus 1 over x ln of x like this with respect to x. This is our p. We are supposed to substitute. But the question is now that you're supposed to ask yourself is, how are you going to integrate this? All right, you have your integral, but how now are you going to have the integral of that part? That is the question, because we are supposed to have what? The integral of this part, which is from this part that we have. All right, so this integral, let us have it aside, because here there's a lot for us to talk about here. So we are supposed to integrate this, all right? So let us see, we are going back to our n5. Here we are going back to our n5. The integral of minus 1 over x ln of x with respect to x. If we check here, we can try to apply the substitution method. This is, we can factor out the negative out, so that will be minus the integral of, we're gonna be left with 1 over x ln of x with respect to x. There's something that is happening about the ln of x. If this is going to cancel somehow, right? This is going to cancel somehow if we let u to be equal to x, because we know from our derivatives this is going to give us what? 1 over x. So we're going to let u to be equal to ln of x. Let's see what's going to happen. If u is equal to the ln of x, that means the derivative of u with respect to x is going to give us 1 over x. Then we make dx the subject, so it means dx is going to be x du. If we cross multiply, this is going to be x du. So that means this integral was going to cancel exactly, because this was going to give us minus 1 over x ln of x, which is u. So the ln of x, remember, it's u here, times dx. In place of dx, we're going to have x du like this. So this and this was going to cancel. So you remain with minus the integral of 1 over u with respect to u, which is minus ln u. All right, remember the integral plus the constant of what? Plus the constant of integration, of which the u that we are referring to in this case is the ln. So it's ln of ln x like this. So this is ln of ln x. All right, take note, ln of ln x. So there's a minus there. So this is going to give us, we are going to have this as, right, let us have this properly. So this will be equal to e to the exponent of, we integrated this, everything, we got minus ln of ln x. This is what we got. Minus ln of ln x. This is what we got. All right. So what does it mean? The constant, like I said, of integration is not important for now. You do not write it. Do not write that one. Remember, I said if we have got an e being raised to the exponent of a ln of x, the answer there is going to be x, the number that, or the term that is affecting ln. So meaning to say, if we write this as a single log, this is going to be e to the exponent. We raise this negative 1 to be the exponent. So it will be ln of ln x like this to the exponent of what? Of negative 1. Remember how you remove this number multiplying a log, it becomes the exponent of the log. So if we check properly here, we are saying e to the exponent of a ln, e to the exponent of a ln here will give us the answer to the ln. The ln here, the part that is being affected by the ln is this part, which is the ln of what? X to the exponent of negative 1. So it means the e to the exponent is going to give us ln x to the exponent of negative 1, which represents our x on this format. All right, the ln, so what represents our x is this ln to the exponent of what? Of negative 1. So remember, to the exponent of negative 1 simply means 1 over. So see, this simply means 1 over what? 1 over ln x. So this is going to be 1 over ln of x like that. So this is our integral factor. This part of the integral factor of e to the exponent of this, it is going to give us 1 over ln x. After all the derivatives made, this and that, the integrals made, substitutions made, we are going to have what? This part. So let us take this into consideration, because the question is saying that if we can have the format one of this nature of a linear, all right, when we are dealing with the first order linear differential equation, if we can have it in this format, therefore it follows that y is equal to, so what does it mean? Therefore it follows what? Y times this, it follows that therefore y times e to the exponent of this p, which is the integral factor that we got here. This is the integral factor, and the integral factor we got what? We got our answer as 1 over ln x. So it is going to be y times 1 over ln x. So this will be 1 over the ln of x is equal to the integral of q. So this is the integral of q, where q is the function of x, which is our q on this side. Remember I said this is our p and this is our q. So q in this case is 1 over x. So this is going to be 1 over x times e, which is again that integral factor that we had. And our integral factor is what? It's this part of 1 over x, 1 over ln x. So this is going to be 1 over the ln of x like this with respect to x. That is what this formula is telling us to do. All right? From what? From a first order of this nature. Therefore, we are supposed to have our solution this way. So it's simply a substitution that you are simply making into the formula. Then from there, we are supposed to make the integral. We are supposed to determine the integral of this part. So this here we can just write as it is y times ln x, or you can even write as y over the ln of x is equal to. So we are supposed to integrate this 1 over x. All right, 1 over x ln of x. We never integrated this thing before. We never integrated this thing before. We integrated this thing before here, but it was a negative. If you check here, it was it there that we did here, this one. So we integrated this before, this one, and it gave us what? 1 over x ln of x. We ended up with minus ln of x because of what? The negative that was outside of the integral. But in this case, we are just focusing with this as it is. So the answer is going to be ln of x. We are not going to repeat something that you integrated before. So this is ln of x on this integral here. So this integral that we are given here is simply a repetition, this one. So it's ln of x. We did this integral before. So this is going to be ln of x like this, plus the constant of integration. Do not redo this substitution. You have done the substitution before already. All right, so this is it. This part that we have just determined is referred to as the general solution. As you know that once we have our constant considered here, this part is our general solution. We still have the general solution here. All right, so this is our general solution. So what we need now is to determine the particular solution. Remember, our question was to determine or to calculate the particular solution at a point 20. So now we need to find the particular solution at a point 20. So at a point 20 like this, what does it mean? I said it means we are given the x value. It's a point that you have. So you've got the x value and the y value. So it means we are simply going to substitute in place of x, we substitute in place of y, that's a 0. So this is going to be 0 over the ln of x, which is ln of 2, is equal to the ln of the ln of x, which is x is 2. So it's the ln of 2 plus the constant. So as we know, guys, 0 divided by a number, that's a 0. So it means our answer, we're going to take this ln to the other side. So it's going to be minus the ln of ln 2 like this, which is going to give us c. So you can write our answer c as this, or you can simplify on your calculator, minus this ln. Let's see, what are you going to have on our calculator? This is going to be minus the ln of, so this is minus the ln of the ln, we open again another, so it's going to be ln of 2 like this. We close this bracket, we close the first one again. So you close 2 brackets there. So this will give us 0.36. So round off to 3 decimal places as the instruction of the question paper. So this will be shift set up, go to the fix here on number 6. You can fix to 3 decimal places, you press 3. So this will give your answer to 3 decimal places, 0.67, and it's a positive, that answer. So C is equal to 0.367. So that means our C is 0.367. So by finding the value of C, what are we going to do with this C? We have to substitute back, that is to find the particular solution. So therefore, our particular solution this time is going to be given as y over the ln of x. So this is y over ln of x is equal to the ln of the ln x. So this is the ln of the ln x like this, plus c, which we got c is what? 0.367. So that is now your particular solution, this one. So the first one, it was the general solution. From the general solution, we determine what? We determine the particular solution. That is the idea of the question. So the particular solution is always at a condition where you have to substitute something, right? You have to substitute a point that you're given. So that is it. That is how you play around with your first order. As you can see there, it was something that was straightforward. These integrals, your substitution from those, your N5 integrations that you were doing. All right, let's check the other part on 4.2. 4.2, we are now given again, it is to determine the general solution in this case, but this one is a second order that we are given. Remember, one, we are supposed to have the format that of a second order, which is supposed to be, yes, okay, this is 4.2. Let's write first what you're given. That's the second derivative in this case of x squared plus dy dx. All right, minus 6y is equal to 2e to the exponent of minus 3x. That is our question that we are given there. So like I said, what you need is the format first, right? We know that the format was supposed to be given in the form of a second derivative of y with respect to x plus b dy dx plus cy is equal to the f of x. So from this format, we are supposed to obtain what is referred to as the auxiliary equation, which is the one that we obtain by letting wherever there is a dy dx to be equal to r. So we're going to let our r to be equal to dy dx, and we're going to let this y to be equal to 1 at a condition where the function of x, f of x, is equal to what? Is equal to 0 at that moment. The whole of this function must be equal to 0. So meaning to say, this is going to give us what at the end? If we let, with these conditions, this will be r squared, because dy dx is represented by what? By r, but there's a squared. So this will be r squared plus r in this case minus y is a 1. So this will be minus 6 times 1, which is minus 6, is equal to the whole of the function of x is what? It's a 0. So you formed an equation where we are supposed to solve for r in this case, which is the one that will give us the values that we use when we are now talking about what? The complementary function, which is the one that we have to obtain from the values of r that we are going to have in this case, right? So as we can check, this is what? A quadratic, like I said. Let's check if we can have factorization here. Do we have factors here? Right, -6. Factors of -6, that can give us a +1. We've got 3, and yes, so there we've got factors. So meaning to say we can use our factorization direct here. All right, so that will be an r here, and r says the coefficient here is a 1. So what are the factors of 6? -6 actually. That these negative factors of -6 must give us what? Must give us a +1. So that's a 3 and a -2. 3 times a -2, that's a -6. 3 plus a -2, that's a +1. So meaning to say here, we have got a +3 And here we've got a minus 2, which is equal to 0. So R is going to be equal to what? If we equate this, this is going to be minus 3 on the other side, or R is equal to minus 2 on the other side is going to be a positive 2. So we have the value of R in this case, R being a minus 2 and our R being a negative 3. So what it means is that from this solution, I want us to have the, okay, let me bring the formula sheet so that we all understand each other here. So I want you to see this. These solutions that we have here, or presentation here that we have on this part up to the last part, they are from our second order differential equation of the in this case, where we are saying if we are given an equation which is our auxiliary equation of AR squared plus BR plus C is equal to 0. Some they can use AM squared plus BM plus C. It's one and the same thing. You can use R, you can use M. So I'm using R because already that's what you have on your formula. They're using R here. So once your equation is in this format, we expect to have two solutions in terms of R. Whether they are not equal, R1 is not equal to R1, or they can be equal. R1 is equal to R2, or we can have an complex solution whereby we're dealing with the complex numbers where we get imaginary values there. So in our case, our solutions, they are different. We have another solution as a negative 3, another solution as a what? As a positive 2. They are not the same. So the condition that we are going to take is this one for our complementary what? Our complementary function. So it means YC is gonna be written in this form. So what does this form mean? All right, I'm gonna write it down so that we properly understand. So from that format, we are given that Y is equal to, if the solutions are different, if R1 is not equal, because this is your R1, this is your R2. So if they are not equal, therefore AY is equal to A e to the exponent of R1x plus B e to the exponent of R2x. That is the format. So this is your complementary function. So you can write this as YC, all right? Where we can substitute now what we are given as the values of R in this case. These are the solutions, R1 and R2. The solutions, we can substitute these solutions, which is what? R1 is negative 3, so it's going to be A e to the exponent of negative 3x, all right? Plus B, it's a constant, e to the exponent of R2, which is 2 in this case, so this will be 2x. So with this complementary function that we have determined here, we are just going to leave it like this. There's nothing that we can determine or have at this point. No, there's nothing. We are going to we must first combine in order to find the value of A and B, provided that this is for a particular solution. Is this for a particular? Yes. No, this one is a general solution. So there's no need for us to even solve anything. But even if you have to solve, you are going to solve it from Y is equal to the complementary function plus the particular integral of YP. So in this case, we have YC, the complementary. We need the particular integral so that we combine to form what is called the general solution. So where do we obtain our complementary, our particular integral? This is not particular solution, no, particular integral. All right, where do we obtain this? This one, I said, the particular integral is always obtained from the solution that we have, this f of x that we are given. We have to tell from that f of x that we have, how is f of x a constant? Is f of x a linear function? Is f of x a quadratic function? Is f of x a trigonometric function of sine and cos? It is different from each. So you must do like at least 3, 4, 5 questions so that you'll be able to see. So this one is an exponential function, 2e to the exponent of minus 3. So how do we expand when we are given an exponential function? All right, this is it. If you are given an exponential function, when there is a constant like this, if you're given this as when you're given a constant and this is e to the exponent of whatever f of x that you're going to have here, and there's a constant there. The particular integral for yp is going to be given as cx. All right, why c? Because here we have already used a and b, so you continue from c. So it is given as a cx times e to the integral, e to the exponent of that function that you have f of x, which is minus 3x. In this case, our f of x is what? It's minus 3x like this. So it's cx. If there was no constant here, if it was just e on this part, you were going to substitute c e to the exponent of 3x like this. But here there's a number, so you substitute as cx. All right, I hope we are together on this part. So I said the complementary, the particular integral, it represents this y here. So it also must give us dy dx, and also must give us the second derivative with respect to x, because it represents y. So meaning to say, on this, we are supposed to find the derivative of y with respect to x. So what is the derivative of y with respect to x for this particular integral that we have? So as you can see, guys, this is a product. All right, so we've got u and v with respect to x here, a function of x. There's also a function of x as a product. So you're going to use our formula u, first derivative of v, plus v, the first derivative of u. So u in this case is going to be this. We're going to take this as our u, which is cx. All right, so that will be cx times the first derivative of v. Remember, the derivative of e, we have to drop this a, which is affecting e, which is minus 3. So that will be minus 3 e to the exponent of minus 3x like this, all right, plus v, which is our v in this case is this part, which is e. So that's e to the exponent of minus 3x times the first derivative of u. So u in this case is this part. We took this, the whole of this part as cx. So if we differentiate cx, we're going to get what? A c. So meaning to say, this was going to give us negative 3 like this, negative 3 cx, all right, e to the exponent. All right, let me write it this way, negative 3c e to the exponent of minus 3x times this x, all right, because we are supposed to properly see our x separated, this one, so it's times x here like this. All right, then here it's going to be plus c, so this will be c e to the exponent of minus 3x like this. So this is our first derivative of y with respect to x. But like I said, it is supposed to be a substitution that is supposed to be made. We have y to be substituted, the derivative to be substituted, which is the first one. We also have the second derivative on the formula. So it means we are supposed to also find the second derivative of y with respect to x. So what will be the second derivative of y with respect to x? We're going to differentiate this. So again, here we've got a product, just like the previous case here, we've got a product. So that means from our product here, we're going to use again the same formula. We're going to take this as our, let us just take this as our u and this as our v. So this is our u, this is our v. So on the formula, we said it's going to be u, take the u as it is, which means this part is going to remain as it is, minus 3c e to the exponent of minus 3x times the first derivative of v, which is our v, is x. So the derivative of x is 1, plus v, which is x. So this will be x times the derivative of u. So u, we are focusing with x. So this minus 3 is supposed to multiply everything. So it's minus 3 times the constant here. So minus 3 times a minus 3c to be a positive 9c. So we've dropped the exponent. That is, the number affecting at the exponent here. Then e remains as it is, e to the exponent of what? Of 3x. So that is our u, the first derivative of u in this case. All right, plus, what about this part here? What is going to happen on this part? If you check, this part is normal. It's not a product. C is a constant, so this is not a product. You just have to differentiate, drop the exponent, multiply z3, minus 3 multiplies c. So it is going to be minus 3. So let's just write minus 3c e to the exponent of minus 3x, like this. All right, so we can just simplify because we need to substitute this later on, remember? So let us just try to substitute properly. So this will be minus 3c, all right, e to the exponent of minus 3x, all right, plus, gonna multiply this, so it will be 9c e to the exponent of minus 3x times this x here, all right? Then this will be minus 3c e to the exponent of minus 3x. There's nothing that you're gonna do. So this is what you do. From that particular integral that we got from this yp expressed this term, we are going to substitute yp, dy dx, and also the second derivative into this original equation that we are given before as it is, so that we can equate to the left-hand side, to the right-hand side what we have. So we're going to take dy, the second derivative of y with respect to x as it is. So this is the second derivative of y with respect to x, which is this one, which is this part as it is. So it means we are going to take the second derivative minus 3c e to the exponent of minus 3x plus 9c e to the exponent of minus 3xx minus 3c e to the exponent of minus 3x. This is our second derivative of y with respect to x. All right, let's move on to the other stage. What is it that we are having on the original derivative? It's plus dy dx. So we are going to add our dy dx. Remember here we simplified our dy dx here. This is our dy dx that we simplified up to this stage. So we are going to take this dy dx as it is, all right? So that is the part, let me just indicate it this way. So we're gonna take this dy dx as it is, the one that we simplified before. So that is gonna be minus 3c. There's nothing that we are multiplying, so we take as it is minus 3c e to the exponent of minus 3x. Then there's another x here, plus c e to the exponent of minus 3x as it is, all right? That is the part of what? Dy dx. Let us move on to the last part, minus 6y. So minus 6y, it means minus 6 is going to multiply y, and y is this original function that we introduced, yp, this one. So we are going to multiply by negative 6. So it's negative 6 times this. So it's just going to be negative 6x cx, negative 6, negative 6 like this, cx, cx e to the exponent of minus 3x. That is what you're supposed to have. So we have substituted everything on the left-hand side. So this part that we have substituted, it is supposed to give us what? 2e to the exponent of minus 3x on the right-hand side. So we're going to equate this to the right-hand side, which is 2e to the exponent of minus 3x. So on the right-hand side, we are given this as equal to 2e to the exponent of minus 3x. So what are we supposed to do? We are supposed to find these values that we have, the value of c. This is the one that we have, so we are supposed to find the value of c. So where can we have the value of c? We just have to focus with where there is x. So in this case, for e, just focus with where we have the coefficient, where we have got an e, like this part, we've got e to the exponent of minus 3x. The coefficient there is what? Is 2. So we are focusing with 2. So 2 is supposed to be equal to, on this side, we just have to, on this part where there's what? E, so this is e to the exponent of minus 3x, this one. So we have got minus 3c there. So this is minus 3c. All right, we move on to the other term, and so on and so on and so on up to the last. So if we move to the second one after this, sorry for that, this x here is gonna be, there's x here, so you can't take this one. So here we're going to take this one. There is also, why is it like it's a repetition here? Minus 3c again. All right, let's see. Minus 3c. All right, here there is x, so you cannot take this because of this x that we have. So we cannot take this. Here there is also e to the exponent of minus x that we like direct. So you're gonna add the c. All right, here there is x here, so you cannot take this. We cannot. All right, so that means this is what we're going to have. So this whole part is equal to what? Is equal to, we are taking on the part Where there's only e, we do not have what x there. So minus 3 minus 3 minus 3, that would be minus 6, and minus 6 plus 1 would be something like minus 5c, which is equal to 2. So it means c is going to be minus 2 over 5. So we are having the value of what? The value of c. So what are we going to do with this value of c that we have determined, the minus 2 over 5? We are going to substitute. Remember, the purpose of this was to have, guys, you see, guys, all this, it was for us to have this yp here, which is our particular integral. So there we said our particular integral is given in the form of what? Yep is cx e to the exponent of, so we are simply substituting here what we got. So we are going to have yp first. So therefore, from this value that we just determined, it follows that yp is going to be c. We got our c, so we are substituting our c. So it's minus 2 over 5. It was x there. Then e to the exponent of what? Of minus 3x, like this. So this is your what? Your particular integral, this one. But what we need is not this. We need the general solution, which is the one that combines everything, both. Where here we wrote about this here. Y is equal to yc plus yp. So therefore, we combine this to bring up or to have our general solution. So therefore, our general solution is going to be equal to yc, which is the complementary function, which is a e to the exponent of minus 3x plus b e to the exponent of 2x. In the first part, this was 2x, e to the exponent of 2x. Then this one is going to be minus 2 over 5, all right? Minus 2 over 5, minus 2 over 5. Then we have got x e to the exponent, all right? This is x e to the exponent of minus 3x, like this. All right, so that is what you're going to have in this case as for your solution at the end. All right, so I want to explain this part, guys, because we might have a confusion. In order for us to bring up this here, because here we are done, I just want to conclude this part because we might have a confusion. It was because, guys, you know, when I'm recording these videos for N6, I'll be very tired. I don't know why. This is what I want us to conclude here. In order for you to obtain your YP, all right, if you are working with an exponential function, all right, we are working with an exponential function. YP was supposed to be given as c e to the exponent of the exponential, like e to the exponent of f of x as it is. That is what we are supposed to have. But if on a condition that I want you to see here, we are given, there is e to the exponent of minus 3x here, e to the exponent of 2x here. So on your part, on your this complementary part here, we have got e to the exponent of minus 3x, e to the exponent of 2x. So this e that we have is the same as also the e that we had before on our original equation here. There is also a 3x, minus 3x there. All right, we check here. There is also a minus 3x also there. So if we are given this condition that we have got a minus 3x on this f of x, all right, on our f of x on e, it is the same as what you have on your yc, like your f of x, it carries e to the exponent of minus 3x. Yc, it was carrying the same. There was e to the exponent of minus 3x. There was an exponent of minus 3x there. As long as those two are the same, this is how you expand this. You're going to use cx. This is how you're going to use. You're going to have cx. But if they were different, you were going to have your yp as c e to the exponent of minus 3x. All right, maybe if what it was a minus 5x, whatever that you have, you are not going to write cx. All right, but once they are the same, that your complementary function, it consists of the same exponent or the same presentation as what you have on your f of x here. You expand this with what? With the cx. All right. I just hope we are together. I just hope we are together on this part.